The next piece of this lesson is still multiplying with radicals, but this time the radicals have more than one term, so they're essentially binomial radical expressions. So I've got an example up here. I'm going to let you look through that one and think it through on your own after you've seen some of mine. The way we do this is we're going to be multiplying using the distributive property. You may have learned this using the acronym FOIL. Anyhow, so we take the first term of this first one and multiply it by each of the terms of the second one. So I'm going to go ahead and write this out long ways. So that would be 2 square root 5 times square root 5. That's this one times this one. And then 2 square root 5 times the second term over here. So times 4 square root 2. And then we would add or subtract. I'm going to put subtract because this one says minus. Now I'm taking the second term from this first one. So minus 3 root 2 times the first term of the second one. And then minus again, 3 root 2 times 4 root 2. Kind of ran over space there. I'll just have to adjust on the second one. All right, so now using the order of operations, I need to do each of these little instances of multiplication before I do any of the addition or subtraction. So we'll start with that. 2 times square root of 5 times square root of 5. Square root of 5 times square root of 5 would be square root of 25, which is 5. The next one here, I've got numbers outside to multiply together. So 2 times 4 is 8. And I've got numbers inside to multiply together. So 5 times 2 is 10. Next one, I've only got one number on the outside. I've got a 3. I have 2 numbers on the inside that I can multiply together. So 2 times 5 is 10. Another minus. This time again, I've got numbers on the outside. So 3 times 4 is 12. The numbers on the inside, 2 times 2 is 4. And so that would be taking the square root of 4, which is a nice even number, nice round number, I should say. It's 2. Happens to be even also, but that was coincidental. All right, I still have some multiplication to do before I can do the addition and subtraction, so I'm going to keep going with that. 2 times 5 is 10. 12 times 2 is 24. And I kind of left a blank in between because these two are like radicals. So they have the same radicand with the same index. So that means I can actually put those together using the just adding or subtracting the coefficients. So 8 minus 3 is 5. And now I can add together the numbers on the outside there. So 10 minus 24 is negative 14. And then the 5 root 10 is not alike with that other number, so I can't do anything to combine them. I have to keep it just like it is. All right, for the next one here, I'm going to go a little bit quicker. So instead of writing out this whole long thing here, which takes a lot of time, I'm just going to go ahead and do the multiplication. So I'm doing root 3 times 4 root 3. So that would be 4 times, and then root 3 times 3, which would be 9. Square root of 9 is 3. So this is 4 times 3, which is 12. Then I'm doing root 3 times in minus root 2. So that's going to be negative. And root 3 and root 2, they're both in radicals. So I'm going to put together the numbers on the inside. So that would be a 6. Now I'm looking at the second term for this one. So 2 root 2 times 4 root 3. They're both positive, so this is going to be plus. 2 times 4 is 8. And the numbers on the inside, 2 times 3 is 6. And then the last one times the last one there. So 2 root 2 times root 2. It's going to be negative because it is positive times a negative. The root 2 and the root 2 makes a root 4, which is 2. So this is 2 times 2. That's just a 4. Now I need to do my addition and subtraction. So I'm going to be putting together my like terms here. My constants, 12 minus 4 would be 8. And then these two here in the middle are like as well. That's a minus 1 root 6 plus 8 root 6. So they do have the same radicand, so that means I can put them together. It's a negative 1 plus 8, so that would be a positive 7 root 6. Okay, now with this one, I did it more like I would actually do my work if I were working this problem. If you didn't quite understand what was going on, this is the right time to stop the video and go through this problem, writing it out long ways just like this so that you can see how I got the numbers that I got here. Going on to the third one. Okay, this time I've just got a single radical expression that I'm going to be multiplying by a binomial radical expression here. So this is just distributing, just like before. So that was really strange. That was supposed to be an arrow. There. Okay, so I'm going to multiply this times root 5, and then I'm going to multiply this times 4 root 2. So 2/5 root 3 times root 5. The 2/5 is just going to stay in the front. And then the root 3 times the root 5, I can multiply those together. So 3 times 5 is 15. And then I've got 2/5 root 3 times 4 root 2. So the 2/5 times 4 would be 8/5. And the root 3 times the root 2 would be root 6. Okay, now the radicands on these two do not match. So that means I cannot combine them. One thing that I could do that you may see in, like, say, a multiple choice situation, since both of these fractions that are here have a 5 denominator, you may actually see this one where they write it as one big fraction like this, and then they just use the numerator and the radical for each of these pieces. So 2 root 15 plus 8 root 6, all of it over 5. So you could see either this, oh, that was really bad. You could see either this or this as a correct answer.